So this is the beginning of a series of lessons on patterns and pattern type problems, which is really an introduction to algebra. So algebra really is the mathematics of patterns, and in this case we're going to just begin to look at the whole idea of a pattern and how to interpret it and how to extend it, and again how to understand how it relates to the whole concept of algebra. So what you see before you is just a basic pattern. We use tiles sometimes to create patterns and just to help develop the skill of seeing and interpreting patterns. So what I have here is what I would consider three figures in a pattern, and it's an increasing pattern. So this first one, if this was figure 1 and this is figure 2 and this is figure 3, you could see how hopefully the idea is that you can, from the initial three figures in the pattern, it's pretty simple to predict the next figure in the pattern and then the next one after that. So we're going to begin with the whole idea of just taking the initial pattern, these three, considering this to be the first figure in the pattern, this the second figure in the pattern, and this the third figure in the pattern, and then trying to predict from there. So if this is the first figure, which is made up of 3 tiles in a line, and this is the second figure made up of 4 tiles in a line, and this is the third figure made up of 5 tiles in a line, then I'm going to slide these over a little bit here so I can make room for some more. And then I think it should be fairly obvious, and I'm going to go ahead and stack them so they just sit like this. The next figure in the pattern, as patterns increase, in this case, would be 1, 2, 3, 4, 5, and then one more tile, 6 tiles. So I hope that sort of is somewhat obvious that if this is our pattern and it starts with 3 tiles and then 4 and then 5, then the next would have 6, and then the next one after that, hopefully understand, would have 7, and so on. And so what I'm going to do is I'm going to switch over to a piece of graph paper and move my tiles off here for a second. So if we remember the initial 3, and I'm actually going to put a picture up, here's the initial 3 that we started with. So figure 1 looks like this, figure 2 looks like this with 4 tiles, figure 3 looks like this with 5 tiles. And so now what if I wanted to extend this pattern and include at least 3 more? So now what I want to do is include figure 4. And so we already know from our previous look at this that figure 4, which I built, had 6 tiles in it. So I'm just going to go 1, 2, 3, 4, 5, 6. So that would be a picture of figure 4, 1, 2, 3, 4, 5, 6. And here again, this is the initial set of these. So I want to make sure we're clear here before I move ahead. This might be super obvious at this point, but I don't want to assume that it is, because this is the beginning of this whole understanding of algebra. And some people think algebra is really complicated mathematics, but it's actually just, again, the whole idea of understanding patterns and how they relate. So here was figure 1. Figure 1 had 3 tiles. Figure 2 has 4 tiles. Figure 3 has 1, 2, 3, 4, 5. And then figure 4, this is the 4th figure in this pattern. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6 tiles. So my little sketch is basically what I'm doing here now as I'm sketching these. So figure 4 would have 1, 2, 3, 4, 5, 6. I'm just going to go ahead and write a 6 at the bottom. And if I did figure 5, so the idea is, well, if I know figure 4 has 6 tiles, and again this pattern seems to be extending itself in a fairly obvious way, then Figure 5 would have 1, 2, 3, 4, 5, 6, 7 tiles. So if you guessed 7 for this next one, you were right. And then figure 6 would have 1, 2, 3, 4, 5, 6, 7, 8. Now I would put these on my screen for you, but I think that they won't fit because they get to be too big. This one has 8 tiles. So I could even number them 1, 2, 3, 4, 5, 6, 7, 8. Make sure I got them all. And 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6. So there is figure 4, 5, and 6. And we could really extend this pattern on forever, which is really the idea, is that if this was something that we wanted to know beyond this, we could continue to do it. And so the whole idea of this now is that I should be able to make some predictions. And I actually have just done figure number 6, which I know has 8 tiles. But what if I want to get to the 10th figure in the pattern? So I'm going to actually go back to now this part. I'll come back to here in a minute because right now I want to make a table. And so this is what we call a tabular or numerical representation of the pattern. And there's sort of 2 parts to my answer here. First part is what I see. And some of this may just seem really obvious at this point, but you'll see what I do with this in just a moment, where it might be very helpful in the algebraic sense of understanding this problem. So for the first figure, figure 1, which I'll go back to for a moment, we know that figure 1 had 3 tiles in it. So I'm going to actually just go figure 1 has 3 tiles. Now you'll see there's a 0 figure in here, and we're going to come back to that in just a moment because the 0 figure can be very helpful. But for right now, I don't know what the 0 figure is. I don't have a 0 figure. But right now I do have the first figure, which I know is 3. And I know the second figure in this pattern has 4. So I can do the second figure has 4. And I know that the third figure, 1, 2, 3, 4, 5. And some of you might be just already saying, well, you know, it's pretty obvious that it's going up by 1 every time. So we could just continue to affirm that by looking at figure 4 has 6. So I go figure 4 has 6. Figure 5 has 7. Figure 6 has 8. And so I could just continue this pattern. This is the whole idea of patterns. Know that it keeps going. So I would hopefully be able to predict that figure 7 has 9, figure 8 has 10, figure 9 has 11, and figure 10 has 12. And so now I could actually make that prediction that figure 10 has 12 tiles in it if I were to keep this pattern going and keep building them, which I could check to see if figure 10 had, if I just continued to build these. But then we really want to extend this pattern even further beyond and say, well, what if I wanted to just jump all the way to figure 30 and not have to keep doing this, add 1 each time, and so just make this jump to this point. So here's where I want to go back to what I see, because what I see in this pattern here is that I have a 3 here and a 1 here. Figure 1 has 3. Figure 2 has 4. Figure 3 has 5. So I could actually go back to my original tiles. There's my figure 1, and my figure 2, and my figure 3, and my figure 4. Now, here's sort of the key to all of these types of patterns when they are increasing by the same amount each time. For instance, this one is always increasing by 1. So whenever I see a pattern that increases by the same amount each time, goes up by 1 each time, what I really want to look for is the figure number in the pattern. So for instance, this is figure 1 right here. And so what I see in figure 1 is I see this 1 tile, which is kind of representative of the figure, and then there's 2 more here that are attached to it. And then if I go to figure number 2, here's 2 tiles for figure number 2, and then there's 2 more attached to it. And some of you are like, well, how do you see that? Well, I'm always looking, first of all, for the figure number. Now you could say, well, there's the figure number, this is figure number 1, so there's 1, 2, 3 there. This is figure number 2, so there's 2 and then 2 more. And this is figure number 3, so there's 3 and 2 more. So there's lots of ways to see this. But just for a second, let's just kind of keep it the way I'm seeing it. And here's figure 4 with 4 tiles and then 2 more. So if you can kind of see the way I broke this down, let me zoom out for just a second so you can see it a little bit better. Here we go. So this is figure 1. This is figure 2. This is figure 3 and figure 4. So what I see is the figure 1 and then 2 more. And then figure 2 has 2 tiles and then 2 more. And then I see figure 3, which has 3 tiles and then 2 more. And I see figure 4, which has the 4 tiles and then 2 more. So what I see sometimes helps me so that I can predict, because really what I see here is 1 plus 2. And so what I see in the second one is 2 plus 2. And what I see in the third one is the 3 plus 2. And what I see in the fourth one is 4 plus 2. And I really literally could go up to the ones that this is figure 6. Or sorry, figure 4, which has 6 in it. And so here are the 4 plus 2. And here's 5 plus 2. And here I see the 6, 1, 2, 3, 4, 5, 6 plus 2. So what I continue to see in the pattern is the figure number plus 2. So figure 6 has 6 plus 2. Figure 7 has 7 plus 2. Figure 8 has 8 plus 2, 9 plus 2, 10. So what I see helps me to figure out this 30th figure. If this is always true, that I have the figure number and 2 more, then the 30th figure should be 30 plus 2, which means it would have 32. And so now I can answer that question as well. And that helps me make that prediction. Now, I actually want to go back to the 0 figure, because if we actually went back 1 figure, which sometimes seems like, well, why would you do that? Well, because it tells you something about the pattern. If I were able to create a 0 figure, and this pattern continued backwards, here we had 4, here we had 3, here we had 2, here we had 1. What would be the 0 figure? Would be none of these. And then you still would actually have 2 tiles represented even in the first figure. The plus 2 is still there. And that holds true with the pattern I see in this part where I call what I see. What I see is 0 plus 2, which is still 2. Now that is going to be an important representation in just a moment when I flip the page and we do some other parts of this. So far we've been able to start with a pattern, a fairly simple pattern. The patterns will become more complex. This is just an introduction to the whole idea of seeing a pattern. First figure, second figure, third figure, extending the pattern, seeing the pattern and how it grows or how it changes, being able to make predictions about different figure numbers or figures, what would they look like, and really honestly we know what this 30th figure looks like. It's a stack of 32 tiles in a row, the figure number plus 2 more, and we could extend that on as far as we want, which is really what algebra does. Now here's where we want to take this to the next place in this problem. We want to graph it. So this is basically called our intro to patterns problem. So I'm going to label this. And this is our tiles. And down here is our figure number. So if we think of the x-axis always as the figure number, in other words, if I look at this, the figure number is x. Now we're going to start getting a little algebra in this, and the number of tiles is y. In other words, I start with a figure number, and when I start with a figure number, then I use that to find the number of tiles. So figure number, if I know it's figure number 2, I'm going to get 4 tiles. And the question is, how do I use the figure number to get the number of tiles? And again, this is our intro to patterns problem. And now we're going to graph this on this chart. And so these are our figure numbers. So figure number 1, if you remember, had 3 tiles in it. So I'm going to put a dot there. And figure number 2 had 4 tiles. And figure number 3 had 5 tiles. And figure number 4 had 6 tiles. So these are like coordinates. 4, 6, 5, 7. These are the points, different places. Figure number 1 had 3 tiles. Figure number 2 had 4 tiles. Figure number 3 had 5 tiles. And really figure number 0 had 2. So and there's that part there, which is going to come into play. And you can really now see where the pattern goes. And really I could just continue this pattern right up the table and keep it going as far as I want. Now here's a point. Some people say, well, should I connect the dots? Well, sure, why not? Because we could actually cut the tiles into half tiles or quarter tiles or pieces of tiles. So we really could have figure numbers, figure 1.5, figure, it depends on what we were trying to figure out, but in this case, you do that. So I'm going to extend this, and knowing that it continues on forever in either direction, I'm going to put an arrow on either end, because our patterns really continue. If it's this type of pattern, we can really extend it as far as we want. Remember, the 30th figure is way out here off of our chart. But we're still able to predict the 30th figure because the pattern is predictable. And so we want to define these different labels here because we have our x and our y, and we're going to use those now to write an algebraic expression or an algebraic representation. So what we just did here was a graphical representation of the pattern. What we first did over here is what's called a tabular or numerical representation. So we make a table and we represent the pattern here. And so now we're going to represent the pattern with an equation. So y is the number of tiles in any particular figure. That's our variable on this side. And x is the figure number. So we're going to use the figure number to help us predict the number of tiles for any figure in this pattern. And so if you think about it, at this point, I'm going to flip back over to here. And if I just add one more line here and consider this to be x. So the figure number, we're just going to call the letter x. It's a variable. It could be any one of these numbers. And if you look at all of these in here, if I take the figure number plus 2, I get the number of tiles. So if I take x plus 2, I get y. Since this is y, and this actually is x, see all these x's here, 1, 2, 3, 4, 5, it's the same value, so whatever x is, plus 2 gives me the number of tiles for any figure. So that's my equation. X plus 2 equals y, where x is the figure number. That's what we defined it as. and y is the number of tiles. So x. So if I'm talking about the 100th figure in this pattern, 100 plus 2 is 100. The 100th figure would have 102 tiles in it, all in one big long stack, one line. And so that's what we want to do when we are coming up with an equation. We want to see the pattern and how it's increasing. You can see it's going up by 1 each time, but it starts with 2 tiles and then just adds 1 on each time. So that's another way to think about what's happening in this particular pattern. Now if we want to put this into context in terms of a geometric representation, if I go back to figure 1, and remember when I was looking at figure 1, this is what I did with it. So here's my figure 1 and my figure 2 and my figure 3, so my original 3 figures. And I said, really what I see is the figure number plus 2. And here I see the figure number plus 2. And here I see the figure number plus 2. So if I wanted to put this in context, in the actual geometric context of what I see and where the equation actually comes from, I could describe it as I see right here. This is equal to x, which in this case is 3 plus 2. And the same is true right here. This set of tiles right here is equal to x plus 2 up here. And this one right here is equal to x, equal to the figure number. If this is x, x equals the figure number. Then I'm taking the figure number plus 2 every time. So the idea of putting this in context or in a contextual representation would be to do what I just did. So if I think of figure 1, here's figure 1, it has 3 tiles in it. And if I think of kind of cutting it into 2 parts, so right there is the figure number, or x, plus 2 more. And if I looked at figure 2 again, which has 4 tiles in it, so here I have, and I'm going to kind of break it up, so this part right here is the same as the figure number, or x, and then we still have these 2 out here that are just always there. Kind of call this this is a constant 2. And if I look at figure 3, which has 1, 2, 3, 4, 5 tiles in it, so if that's my figure 3, it would have, here's my x plus 2. X is representative of the figure number, equal to the figure number, and so now I have a contextual or a context. X is equal to the figure number, and then I'm always adding these 2 on the top to extend the pattern, and this would go on forever. And so now if I were to ask for any figure number 500, you would know exactly what it looks like. It would be a stack of 500 tiles plus 2 on the top, so it would be 502 tiles total. And again, this is a very simple problem, should be a simple problem. It may seem complex at the moment. The patterns will get much more difficult. So the idea here would be to understand where each of these pieces comes from at this point. And maybe go back through this again. Now there's one last piece, because we always want to be able to put this in words. What does this mean? If I want to describe in words without using x's and y's and all this algebra, how to find the number of tiles for any figure. So in other words, I want to put this equation into words. So I don't want to use x and y and all this stuff. I want to put it in real terms that I could describe to somebody, almost like directions. If I want to find the number of tiles for any figure number, what do I do? So that's actually what I'm going to do. I'm going to say to find the number of tiles for any figure in this pattern. Then I'm going to really go back to my equation. What does my equation say? It says take the figure number, which is what x represents, and add 2. So to find the number of tiles for any figure in the pattern, this pattern, take the figure number plus 2. And so now I could describe in words how to find the number of tiles for any figure. So again, example, figure number 1000. To find the number of tiles for figure number 1000, I take the figure number 1000 plus 2. So there would be 1002 tiles stacked in one long stack in figure number 1000. And that's the whole idea of patterns and equations and representing them in these different ways. This is actually called the 5 ways to represent an equation or to represent a pattern. So the first way we have is this numerical tabular way, where we start with each of these representations and we can compare them to the number in each figure. So our tabular numerical representation is the first way. We have a graphical representation where we make a graph of the pattern. So this is what the pattern looks like in terms of how it's changing and growing. We have an algebraic representation in an equation. This is sort of what we consider to be what we normally see with algebra, is some sort of an equation that represents something that's changing. See, x is changing and so is y. As x changes, so does y in a predictable way. And that's what algebra allows us to do. So that's our algebraic representation. And then we put it in context. We say, what does it look like in the real world, in the real tiles? How do the tiles show it? Here's where the tiles show the figure number plus 2. Here's where the tiles show the figure number plus 2. So that equation actually is represented in the tiles. And then finally we use a verbal representation so that we can actually put it in words and describe it in terms of how the pattern is changing. And that actually represents the 5 ways to do that. And so I'm going to show you these are the 5 ways to represent the answer to an increasing pattern problems. And so we start with our numerical tabular representation. Sometimes we can even go extend the pattern into negative numbers because patterns extend both directions. And we talk about the figure number, number of tiles. We have a graphical representation of it, showing how it's increasing from left to right. We have an algebraic representation using the figure number and the number of tiles needed to make a figure. We have a geometric or contextual representation where we have our figure number plus 2, our figure number plus 2, our figure number plus 2. And we have our verbal representation, which can be written in many different ways. In this case, I wrote it, you start with 2 tiles and then add 1 each time. So to find the number of tiles for any figure, you take the figure number plus 2. So a little bit more extensive description. But again, 5 ways of representing an increasing pattern. So that was a pretty long lesson. It might be one you want to go back through again if you're not sure about any of those parts. There'll be an additional lessons on this if you want to look at some other patterns and see how I solved those, and maybe that will help you as you begin to explore these patterns on your own throughout the lessons ahead as we look at increasing patterns.